Dear students, today we'll see how do we use Zener Diode as voltage regulator. Now first, if you know the meaning of voltage regulator, it says that the output voltage should remain constant. The output voltage of any circuit should remain constant in spite of variations in the input voltage or variations in the load. So even if there is variation in the input voltage, the output voltage should remain constant, and even if there is any variation in the load, the output voltage should remain constant. This is what is the definition of voltage regulation. So if you are varying the input voltage and keeping the output voltage constant, it is called as line regulation. If you are varying the load and keeping the output voltage constant, then it is called as load regulation. So both these cases we will see by using a Zener diode as a voltage regulator. So here you can see the circuit. In the circuit we have used a Zener diode. So here you can see there is a Zener diode which is connected in a reverse bias condition. So this Zener diode cathode point is connected to positive of the terminal and anode point is connected to negative of this battery. So for the input voltage, if you are having positive and negative, then the positive of the input voltage is connected to the cathode of the Zener diode and negative of the input voltage is connected to the anode of the Zener diode. That means Zener diode is connected in a reverse bias condition. So this is a protective R resistor and this is a load resistance RL. Okay. Now here this Zener diode, if you want to use it as a voltage regulator, then it should be used for a voltage above the Zener voltage. That means if you see the reverse bias characteristics of a Zener diode, if you see, then this is voltage minus current. This will come like this and you can see a sharp breakdown. You can see a sharp breakdown. This will come like this. You can see a sharp breakdown. Now this sharp breakdown takes place at the breakdown voltage. That breakdown voltage will be called as Zener voltage. Zener voltage. So Zener voltage can be of 6 volt. Zener voltage can be of 12 volt according to which Zener you are going to use. Okay. Now here in this graph we see that the voltage, breakdown voltage, that is the Zener voltage, will remain constant and the current, Zener current IZ, will be increasing or decreasing. So this is the area in which you are going to operate the Zener diode when you are using it as a voltage regulator. This is first thing what you have to remember. Okay. Now, if you see this circuit, this is the input voltage, this is a protective R resistor, this is the Zener diode, and this is the load. And the output of the load, that is V out, is equal to IL into RL. That is load current into load resistance. Now, if you see here, this is the input current IS. This is the Zener current IZ and this is the load current IL. So here if you see IS at this node will be divided into two branches. So IS is equal to IZ plus IL. This is an important equation. IS is equal to IZ plus IL. This is an important equation to understand Zener diode as voltage regulator. Now here if you see, if we first consider line regulation, if the input voltage goes above 6 volt or 12 volt, whatever Zener voltage is there, if it goes above that, in that case the voltage across the Zener will remain constant at a particular Zener voltage and hence the output also will remain constant. The Zener voltage will remain constant and hence the output voltage will also remain constant. And if you speak about a current, when IS increases, if this increases, okay, IZ will also increase and IL will remain constant. So that means the Zener is going to compensate for the increased current. That means the voltage across the Zener will remain constant, and hence the same voltage across the output will also remain constant. That is IL into RL, that is output voltage, will remain constant even if the input voltage increases above the Zener voltage. Or in that range only, even if it decreases above the Zener voltage, at that time also this V0 is going to remain constant, because IZ will be always adjusting. Zener current will be always adjusting, keeping the load current constant. Okay, this is what we see for line regulation. Similarly, for load regulation, say if the output load resistance is varying, that means it will draw more current, so that current variation will be there. Now, when it is varying and it wants to draw more current, that time this Zener diode will become active. And it will draw more current, and it will see that the IL which is going to the RL is giving you the constant voltage. So if RL is increasing, IL will decrease. If RL decreases, IL will increase. Okay, so depending upon whether RL is going to be less or more. So here we have a relation for output voltage. V0 is equal to IL RL. If RL, that is load, decreases, then IL will increase, and if load increases, IL will decrease, and in both the cases it will see that the output voltage remains constant. And for that variation of IL, IZ will be always compensating. The Zener diode current will be always compensating. That is, this range of the graph we are going to use. It will either become less or more depending on how much to keep IL. IL should be less or more depending on how to keep the output voltage constant. That means even if the load varies, load resistance varies, in that case also output voltage will remain constant. That means for line regulation and load regulation, for both you can use Zener diode as a voltage regulator. So here, in both the cases, whether it is variation in the input voltage or there is variation in the load resistance, whether it is variation in input voltage or variation in load resistance, that means whether we are speaking about line voltage, okay, line regulation, or load voltage or load regulation. In both the cases, the output voltage will remain constant because of the use of Zener diode. So here, Zener diode is keeping the output voltage across the load constant in spite of variation in input voltage or in spite of variation in the load resistance. In both the cases, the output voltage IL into RL, V0 is equal to IL into RL, V0 will remain constant. That means this is an example of voltage regulator. So here, Zener diode is being used as a voltage regulator, and it is used in reverse bias condition. This is the area which is important in which we are going to use the Zener diode as a voltage regulator.